All right, it's about time, so let's get started. Hello, everyone. My name is Mete Atamel. I'm a developer advocate at Google. I'm based in London. It's actually my second time in Crete. I came here 6 years ago, and it's been a while since I'm here, so it's great to be back. And today I will be talking to you about how do you evaluate, how do you test, how do you secure large language model applications. It's basically what I learned when I was building LLM applications and some of the tools that I used and some of the things that worked and some of the things that didn't work. So it's kind of like a survey of what I know. And I'm very interested in hearing from you afterwards if you use any of these tools or if you use some other tool that I don't know about. So please come and talk to me. The presentation is already on speaker deck. So if you go to this link, you will have the presentation if you want. And the demos that I'm going to show, they're already on this GitHub link. And I'm going to share this at the end of the presentation. So you have everything from today if you want to. Before I start, who is actually running a production application using large language models today? Anyone? A few people. OK. So I think most people are at this stage where they're using LLMs for their own productivity. Maybe they started using LLMs for their own applications as a prototype, but not so much on production level. And then once you start using it in the production, then you run into these problems that I'll talk about. So maybe this will be useful as we move into the space where we'll use LLMs more and more. So I think it's very easy to get large language models generate content. It's literally a single API call in most models. Like you just say, generate text, generate image, generate sound, whatever, with a single call, with some parameters, you get some content back. I think that's the easy part. And actually, it's almost like too easy that people forget that, maybe we should care about what we get back. But I think what's very difficult is that to make sure that what you are getting back, the output of the model, is actually good, right? And by good, like, I put good in quotation marks because it can mean different things to different people. So what does it mean for an LLM output to be good? Maybe you are looking for a certain structure. You want the LLM output to be in a certain format, and as long as it adheres to that format, then that's a good enough output for you. Or maybe you want correctness. So you want to make sure that what you're getting back is actually factually correct, and you don't want hallucinations. So maybe that's the most important thing for your application. Or maybe you want relevant answers, because if I ask about how is the weather in Crete, I don't want to get the weather of London, even though it might be correct, it's not relevant to my question. Or maybe you want groundedness. So maybe you have some kind of documents, PDFs, and you want the large language model to base its answer based on those PDFs and nothing else. Maybe you want non-toxic answers, or maybe you want to make sure that your model actually uses the right tools that you specify at the right time, and so on and so forth, right? And maybe it's a combination of these things, and maybe you want all of them, and actually it's hard to get all of them, but maybe you want a combination of them, and that's good enough for you. On the topic of structured outputs, when large language models first happened like a couple of years ago, you used to get all sorts of structures back. Like you would get free text, you would get Markdown, you would get JSON, you would get malformed JSON. So you had to do a lot of checking once you get the output to make sure that it's in the right format that you want, or you had to do a lot of prompting to make sure that you get good structures. Actually, nowadays, it's quite easy to get structured outputs with most models. There's a library called Pydantic in Python, and most models allow you to define a schema using these Pydantic classes. So for example, here we are defining a very simple recipe class with a name and description and a list of ingredients. And then when you generate content, you can say, OK, give me a list of few popular cookie recipes. But then in the configuration, you specify that you want JSON, but you also want to make sure that that JSON adheres to this schema. So this is from Gemini, Google's model. But most models, they allow you to specify something like this. And with that, you get a JSON back and with this structure that you're expecting. And these structures, they can be as complicated as you want. Of course, you don't want them too complicated, then LLMs kind of get confused a little bit. But as long as they're a few levels down, then you usually get the structure, and the structured LLM output is not a problem anymore. Usually you get what you ask for. But then for the rest of the things, to know that the output is good, you need to actually measure what you get back. But then the question becomes, what do you measure and how do you measure it? And that's what this talk is about. So let's go through some of the things that I know in this area. Well, whenever you talk about LLM outputs and measuring them, you will eventually get into what's called evaluation framework. So you will probably need some kind of framework to use, unless you want to measure everything on your own, but then that takes time, so it makes sense to use a framework. And when you look at this area, depends where you run. Like, for example, if you're running on Google Cloud, there's something called Vertex AI, which is the AI part of Google Cloud. And then within Vertex AI, there's something called Gen AI Evaluation Service. So you would typically use this because it's already there and you're already running in Google Cloud. But if you want to stay in open source, there's another one called DeepEval, which is an evaluation framework in Python. There's another one called Ragas, which is an evaluation framework mostly focused on retrieval augmented generation. There's another one called Promptfoo, which is a security framework and also an evaluation framework. There's another one called TrueLens, and there are more. There are more, right? I mean, these are the ones that I mainly tried and worked. So you basically have to do your research a little bit and see, which frameworks exist and which one you want to use. Now, once you look at these frameworks, you'll realize that they come with some metrics. So, for example, if you look at DeepEval, it has these kind of metrics like G-eval, faithfulness, precision, recall, task completion, so on and so forth. But then if you look at Promptfoo, it also has some of the metrics. So, for example, it also has G-eval and relevance and recall. But then it also have the other things like LLM rubric or model-graded closed Q&A. So different metrics. And then if you look at Ragas, this is more for retrieval augmented generation. And then you see that it started with metrics for RAG applications. So again, precision, recall, so on and so forth. But then it also started adding agents and tool use cases as well. And then you will also see that in DeepEval as well, you started having agent and tool metrics. So my point here is that depending on the framework that you're using, you get different metrics. Some of them match, some of them don't match. So then you kind of have to figure out like which metric you care about and then see if the framework supports that, or vice versa. Maybe you choose a framework and then see what you can do with that. And you probably also need to do a little bit of mix and match. Like maybe you use DeepEval for basic kind of metrics, but then maybe for retrieval augmented generation, you want to use Raga. So it can be a little bit of mix and match as well. So there's no right answer really which framework to use. I don't think there's one framework that I've seen that's like the best that you could use. But when you look at metrics, I think in general they fall into two different categories. The first ones are called statistical or computational or deterministic metrics. And these are metrics that are basically mathematical functions, and then you pass your output to them, and they give you a score. So that's why they're called statistical or deterministic metrics. So Blue, Rouge, Meteor are some of them. And the other class of metrics is what's called model-based metrics. So the idea here is that you use a large language model to get an output, and then you use another large language model to evaluate the output of that model. And then there's some things in the middle, like they kind of combine both. They try to do statistics, but they also use a model to do that. I haven't really looked into this area, and I kind of find it complicated. I feel like you probably start with statistical metrics first, and then you will pretty soon move into model-based metrics, and I'll explain why that's the case. There's a good blog post here from Confident AI. These are the people who created DeepEval. And they talk about all these metrics and what they do and why they're better in some ways, but they're not so good in other ways. And I'll go through some of that in the presentation as well, but it's a good read if you want to learn more about this. Now, in terms of deterministic or computational or statistical metrics, however you want to call it, first, you can start with something simple. Like if your output, if your LLM output has to have certain strings, or then you can do like basically simple string comparison. So you can do equals, contains any, starts with, so on and so forth. And for this, you don't even need a framework. You can do this with your own language. But most of the frameworks, they include them, because if you're using the framework already, you might as well do the simple stuff first. So you will start with this, but these are very, deterministic. So sometimes you want something like similarity. So if you are doing equals, it's not going to really give you the answer you need, because equals is either true or false. And sometimes the answer is not true or false. It might be like, oh yeah, it's similar enough or not. So you will start with this, but then you will move into other things like Blue, for example, which measures how closely the response matches with the reference. So let's say you have a reference that you're expecting from the LLM, then you get a response back, and then you run this Blue function, and then that gives you a score to tell you how similar is it, the response to the reference. And then there's another one called Rouge. It's similar to Blue, but it's mostly for summarization. So let's say you have some text that you want to summarize, then you have a reference summary, and then with Rouge, you can basically calculate how close the summary is to the reference that I'm expecting. And then there are others like Meteor and so on and so forth. But the problem with these metrics is that, number one, you need a reference data set. So you need, like both in Blue and Rouge, or even with equals, like you need something to compare to. So you need to know what you're expecting. And if you have that, great. But then if you don't have a reference data set, then you can't use them, right? And the second and the bigger problem is that these metrics, they really fall short in capturing the semantic nuances of languages. Because languages, we inherently understand them. We understand when two sentences are kind of similar. But when you try to use mathematics to determine that, they actually don't do a good job of that. So you would realize very quickly that, for maybe simple strings, this might work, but then as soon as you get into more complicated strings, then these scores, they don't tend to work that well. And actually, I'll show you an example of this. So let's look at an example from Vertex AI, Gen AI Evaluation Service. And I'm going to show you different tools for different things so that you get an idea of what kind of tools exist. So in this case, I'm showing you Gen AI Evaluation Service. And in here, they call these computation-based metrics. And then by default, the Gen AI Evaluation Service has these metrics out of the box. So it can do exact matching, Blue, Rouge, and different flavors of Rouge if you want. And the way you define this, I'll just show you an example, is that, for example, here I have a Python file. And then let's say I get some responses from my LLM. So typically what you would do is that you would run some tests against your LLM, and then you save your responses to a file, and then later, when you want to test, you will get the responses and load them up and then run your evaluation. So let's assume that we did that and we got these responses from the LLM. Then we need to have reference. So let's say these are our references that I want to compare against. And then you create an evaluation data set where I have my responses and references. And then you define your metrics. So in here, I'm defining the exact match metrics, the Blue, the Rouge, and then I run my task, and then this runs in the cloud, does all the calculations, and gives me the scores. So let's actually run this. It should be quick. And you will see how these scores are not that useful, and you'll see why that's the case. So I'm running this, and then it's quick because my sentences are very short and all that. And then let's see what scores I'm getting. So for example, when we get the response, hello, how are you, from the LLM, and if I compare it to hello, how are you, the exact match, then for exact match score, I get 1, which makes sense. Then for Blue, I get 1, and for Rouge, I get 1. So they all say it's the same thing. Yeah, great. But as soon as things start changing slightly, then scores will go down. So if I get the response, I'm good, versus I am good, right? They're almost the same thing, except here we are saying I am instead of I am. Exact match is 0, because it didn't match. But Blue is 18, 0.18, and Rouge is 0.66, right? So you see that the Blue score is already not doing well. The reason is because this is a short sentence, and a small change in the short sentence makes a big difference. So that's why it doesn't think that they are similar. but in our minds, we know that it's the same thing, right? And the same thing here, the cat lay on the mat versus the cat sat on the mat. I mean, it's not exactly the same, but again, for us, we would think that that's almost the same. But again, the exact match is 0, blue score is 48%, and rouge is slightly better with 83%. So that's what I mean by these deterministic metrics not being that great. Now, what you would do next is you would try model gradient metrics. And in here, there's a lot of different metrics you can measure. There's a metric called GEval, which is based on a paper that you can read about, and it evaluates, it's a general evaluation metric, but there are more specific metrics like, you can look for hallucinations, you can look for answer relevancy, you can look for summarization. So given a summary, how good is it? Tool correctness, so on and so forth. And the idea here is that you use another LLM, a judge LLM, to measure these metrics, okay? But then at this point, you might be asking to yourself, can I actually rely on a model to be a judge? Because the models, they're not deterministic, so does it actually make sense to rely on a model to do these measurements? And according to this paper, this judging LLM as a judge paper that you can get the link here, they're actually as good as human evaluators. So apparently, even if you use humans to do these kind of evaluations, humans tend to agree 80% of the time with each other. So even two people don't agree all the time whether a summary is good or not, okay? And large language models, with the right kind of prompt, they also do around 80% good of a job for these metrics. So apparently they can be as good as people, but the key is to make sure that you are writing good prompts for the judge model so that it knows exactly what it's measuring. There's a good rubric around it. Yeah, and I'll actually show examples of this as we go through. Yeah, so here I have a few examples from Promptfoo, DeepEval, and also Gen AI Evaluation Source. So let me just show you a couple of quick examples on how this works. So for example, in Promptfoo, which is an evaluation framework, you define your evaluations in YAML, which I don't personally like because I feel like YAML is more for configuration, but that's what they have. And in this YAML, you specify the models that you want to test against. So here I'm using Gemini 2.0 and Gemini 1.5 Flash. Then I define my tests, and they have deterministic metrics, and they also have model assisted metrics. So for example, the deterministic metric here is this one. Let's say our prompt is, what's the capital of Cyprus? And then what we want to test is contain. So as long as the response contains Nicosia, then we want to accept this test. So this is a deterministic metric because we are basically doing a string matching. There's no model involved here. And there's a bunch of different deterministic metrics that you can test. The link is here to look at them. And then there's also model assisted metrics. So for example, if you want to test the question of what's the weather like in London generally, I mean, the answer is, you know the weather in London is always bad, right? It's always rainy. But the way you can say this can change a lot, right? So that's why you can't really do a string matching. Instead, you do a similarity matching. So here, you would use a model to see how similar is it to the value that I'm providing. So here, the value is mild and rainy, and we will check similarity against that. And then, of course, with similarity, you have to give a threshold because, how similar is it? Is it like, so when do you want the test to pass? And in this case, I just chose the threshold to be 70%. So as long as we get a response that's like 70% similar to this, we'll accept that as a passed test. So these are just two very simple examples of how you can do tests in Promptfoo. And actually, the way you run this is that you just say Promptfoo eval and point to your YAML file. And if you run this, we should get a response back, and then we'll see what we get. So you see that for the first question, it passed. And then for the second question, it failed because the similarity was 53%, so that was lower than what we expected. So that's Promptfoo. DeepEval is another one, and actually it's my favorite one for evaluations. And the reason for that is that they let you write these tests in code, and I feel like it's the right thing to do. And they also give you a lot of metrics out of the box, so you don't have to write these metrics on your own. So for example, let's say we want to test answer relevancy. So given a question, how relevant is the answer? The way you would test this is that first you define your models. So first you have your test model, so the model that you want to test. And then you also have an evaluation model that you'll use to judge the other model. Then you write your test case. So first we create a Gemini client to talk to our model. This is our prompt, why is sky blue? Then we get a response. This is the response from the LLM. Then we want to evaluate that, so we create a test case. So this is kind of like a unit test, but for large language models. So in the test case, we pass in the input. We input meaning the prompt, and then we pass in the output that we got from the LLM. Then we create our evaluation model. Then we create our metric that we want to test. So in this case, the metric is answer relevancy. And threshold, again, you need to set a threshold, in this case 80%. And then you just assert the test. So what this will do is that it will run the test case, use the judge model, and see if the answer we got is relevant or not. And just to show you that this actually works, and the way you run this is DeepEval test run, and then we'll run that. And then with that, we should get an answer back. So this way, you can write different tests with different thresholds and then kind of run them and see what kind of scores you get. And if you change something if something changes in the model or in your application, then you can see if the scores are increasing or decreasing. So one thing to keep in mind with these scores is that they are not deterministic, meaning you will not get the same score twice because there's no mathematical function that you are running through it. You are basically using a model to score. So in this case, for example, the score the score that the model gave for this case was 1, meaning the answer is totally relevant. But next time you run, you might get 0.9 or 0.8. So it's never the same, and that's the way models work, and we need to get used to that. Basically, I know as software engineers we want determinism, but at the same time we are in this new world where it's not deterministic. But I think what's important is not the actual number, or what's important is how the numbers change. So if you change your code, are the numbers increasing or decreasing? So that's usually consistent. So you can rely on that instead of relying on the actual number. So you see, this is what you get. And just to show you one more example, let's say you want to test summarization. Then you can use summarization metric, and it's almost the same, except let's say you want to summarize this text. Then what you would do is that you would create this summarization metric, but then this metric has some assessment questions that you can pass in. So you're basically telling the model, these are the questions I want to make sure that the summary includes. And then the model will use that as a way to judge the summary, right? And if you run this, you'll get a score, and then you can see how it does. So that's DeepEval. And then last but not least is if you want to do these kind of things in Vertex AI, then they have this they call it point-wise metrics. But basically, it's the same kind of thing. You have your context and prompt. You have your evaluation data set. Then you have a lot of metrics out of the box. So in this case, we are checking the fluency of the output. And then you just run it against an evaluation task. And in the end, you get a score. And as you see, like the metrics here these are the out-of-the-box metrics that comes with Gen AI evaluation service. They're different than DeepEval, so you need to look into like what you care about and see if the framework supports that. But actually, these metrics, they're just prompts in the end. And you can actually go and see the prompt underneath this fluency or groundedness. So you can look at the prompt and you can actually write your own if you want. So you can customize these metrics as much as you want. But I suggest that you start with what's out there already and then see if that works, and then you can customize it later if it doesn't. So that's model-graded metrics. Then when you are building LLM applications, at some point, you want to ground your responses with your own data. And for that, you would probably use something called retrieval augmented generation. And the idea of retrieval augmented generation is that you would take your data, you would chunk that into smaller pieces. You would put them in a vector database with their scores. And then when a person asks a question, then you go and find the relevant documents from the vector database, and then you feed that to the LLM as context. And with that, the LLM can answer better. Basically, it will use that context, and it will constrict its responses to the context. That way, you get less hallucinations, and you also get extra data to the LLM with your own data, basically. So that's what RAG is in a nutshell. But then there's a lot of nuances with RAG. You know, how do you get your documents? How do you store them? How do you retrieve them? So that's why you need to measure your RAG systems. And in a typical RAG pipeline, you have a retriever. So this is the thing that retrieves the relevant documents from your vector database. And then once you retrieve them, you pass them to the generator, and that's the piece that generates the actual output, right? So that's the RAG pipeline. And for each piece, you have different metrics that you can measure, and we'll go through them, the retrieval metrics and also the generator metrics. So for retrieval metrics, there's something called context relevance. So this is about, you know, how relevant is the context for the input. So if I give an input, the prompt, am I getting the right context? Am I getting the right documents for that input? There's something called recall, context recall. So did we fetch all the relevant information, or did we leave something out? Another one is context precision. So we'll fetch things, but are they in the right order? Because we want to make sure that we are fetching the most relevant documents first, and the least relevant documents the least. So the order kind of matters. So that's retrieval metrics. So this is all about, like, when a user asks a question, are we retrieving the right documents in the right order, basically? And then once you have the context, you pass that to the model, and then that will generate some output, right? And there, we care about answer relevance. You know, is the output even relevant to the question that the user is asking? And the second thing is faithfulness, or also known as groundedness, which means, does the output actually align with the context? Because in some cases, you can pass the context to the LLM and say, please generate using this context, but then the LLM completely ignores what you pass, and it still does hallucinations. So that's why you need to measure them. So these are the metrics that you can measure. As you see, the recall and precision, they require an expected output, meaning you need reference data to be able to measure them. And because of that, people tend to ignore them. So they actually don't measure them, and instead they measure context relevance, answer relevance, and faithfulness, because it's easier. You don't need reference data. So there's something called RAG triad that measures context relevance, groundedness, and answer relevance. And just like I explained, context relevance measures, is the retrieved context relevant to the question? Groundedness tries to answer, is the response supported by the context? And then answer relevance answers the question of, is the answer actually relevant to the question? So that's what you tend to see with RAG systems. And I actually have a couple of examples of this. So in DeepEval, they have these metrics out of the box that you can use to measure. And then in Gen AI Evaluation Service, you don't have these defined by default, but I show you how you can write prompts to define them. And let me just show them quickly to you. I won't run them, but I'll just show them quickly. So if we go to DeepEval, for example, and if you look at RAG, for example, RAG triad, you will see that, you know, we create a test case, then we create our metrics, which are there out of the box, and then we put them together into metrics, and then we just run our test case, and by default, we'll have these 3 metrics that we can measure. Whereas in Gen AI Evaluation Service, we don't have that, so we have to define our metrics. So let me see if I can find that. Yeah, RAG, for example, here I'm defining metrics myself, and I just want to show you that all this stuff is not magic. It's actually just prompts that you can define. So here, for example, I'm defining the answer relevance metric, and then Vertex AI gives you this template. So basically, these are classes that you can use to define your prompts. So here, I'm defining my criteria, so what I'm testing. So for answer relevance, I'm just checking the response and the prompt. I'm ignoring the context, because context is not relevant for answer relevance. And all I'm checking is that is the response relevant to the question, basically. And then this is the definition of our metric. And then we're also giving a rubric. So how do you score it? And in here, I choose a very simple 1 to 4 scoring, where 1 is like the response is totally irrelevant, whereas 4 is the response is totally relevant. So by doing this for answer relevance and also context relevance and also groundedness, you can look at the details later if you like, you get rank triad in your framework as well. So it just, at the end of the day, just prompts that you provide to the judge model. All right, time is going fast. More recently, our LLMs, they started doing more things beyond generating text. So one of them is tools, like so LLMs can call functions to do things. So for that, there are tool metrics that you can measure. So for example, you can measure whether the tool call is valid, whether the tool call name matches, whether the key and value of the tool calls matches, so on and so forth. And then we also started having agents, where this is LLMs plus tools and reasoning, basically. And in agents, you can measure the response of the agent, just like you can measure the response of the model itself. But also in agents, what's important is to measure the trajectory of the agent. Because usually agents, they will call multiple tools in certain order. And you care about the output eventually, but you also care about how are those tools being called? Are they called in the right order that you're expecting, and so on and so forth. So for that, there's like, trajectory exact match, trajectory order, does it match, or is it in any order, so on and so forth. And again, depending on the framework that you're using, there's different ways that you are measuring this. I won't show, like in Vertex AI Gen AI Evaluation Service, there's these tool and agent metrics out of the box, but I won't show them here. If you're interested, you can check them out from the links that I provide. And then you also might be wondering at this point about multimodal LLMs, because right now I only talked about LLM outputs that are text-based, but we know that LLMs now can generate also images and videos and audio and so on and so forth. So how do you measure those? There's something called Gecko, which is a method to measure text-to-image and text-to-video models. So if you have a certain text to generate an image, or if you have a text to generate a certain video, then you can use Gecko to measure that. And I have an example of this in the repo as well, just to show you briefly how that looks like. Yeah, so the way Gecko works, and again, all of this is based on a paper that you can read. But basically, let's say we have this prompt, like streaming cup of coffee and a croissant on a table. Like that's the prompt that we are using to generate an image. What Gecko does is it goes through this 3 steps to take the prompt, figure out the different parts of the prompt, and then from there it generates questions automatically. So what it will do is that it will look at this prompt and it will generate these questions of, is the cup of coffee streaming? Is there a cup of coffee? Is there a croissant? Is there a table, right? And then it will look at the image that was generated, and then it will see whether the image matches the answer that it's expecting. So we are expecting these to be all yes, and it will go and look at the image using the model, and it will see if these are yes, and if so, the score will be 1. So I have all the details of how to set this up. Again, it's all prompts, and I can actually even show you the prompt. So you see there's a rubric generation prompt with some examples of what we're expecting the model to do. And once the rubric is generated, so these are the questions that are being generated, then there's a rubric validation prompt that will go through those answers and it will give the scores, and then you take the scores and average them out, and then you have your score. So you see it's slightly complicated, but with some examples, it's not that difficult to do. And this same thing for videos as well. You use the same method for videos. All right. So that's kind of what I know about evaluations, but we still need to care about inputs and outputs to our models, because people can pass in bad stuff to our LLM, and then LLMs can say stupid things. So we need to actually detect and block them. And actually, there's this paper that comes out every year that talks about all the different top 10 security problems that your LLM applications can have. And then Promptfoo, they have a blog post that kind of goes through them and explains to you how you can detect these problems and how you can actually stop them. So feel free to check them out. I won't show you now because I don't have time. But for this kind of issues, you again need some security framework. And again, it depends on where you're running. So if you're on Google Cloud, there's something called Model Armor that tries to basically block inputs and outputs. Promptfoo can be used for this as well. There's something else called LLM Guard that I use that sits in the middle and kind of looks at your inputs and outputs and tries to block things when you don't want them. There's another one called Guardrails AI. I don't know if you use anything else. If you did, let me know. And I have examples of all. So you can look at the examples of Promptfoo, LLM Guard, and Model Armor. I will actually show you, maybe not the Promptfoo, but the LLM Guard is one of the useful ones. So the way LLM Guard works is that it kind of sits in the middle of your application and the model, and then it checks the inputs and the outputs. And the way it checks this is that you create what's called input scanners. So let's say you want to ban code, because code in prompts usually means someone is trying to run some code which you probably don't want. So let's say you have your prompt that has some kind of code. You create an input scanner, and then there's a bunch of different scanners that you can apply. In this case, we're applying code scanner, so ban code. And then before you pass your prompt to the LLM, you pass it through the ban code scanner. And then with that, you get a response whether it's valid or not. And that way, you can block that to get to your LLM. So there are things like banning code. You can ban certain topics, for example, politics. Then there's output scanners that apply from your model to the application. So you can block like gibberish. You can block certain languages. And you can even do anonymize and de-anonymize. So let's say you have this prompt where you are asking the model to make some SQL statement for some person. But then this prompt has some personal data. It has the name of the person, email of the person, the IP address, so on and so forth. You probably don't want to pass that to the model because you don't know what's going to happen to that data. But what you can do is that you can pass it through an anonymized input scanner. And then what this does is that it looks at your prompt and it anonymizes it. As you see, the email and the phone number is redacted. And then you pass that to the LLM. LLM gives you the SQL statement. And then on the way out, you de-anonymize it. And you get back a SQL statement that you can actually use in your application. And the idea here is that you are basically masking and unmasking your inputs and outputs so that you don't have to pass them to the LLM. And you can also chain these input and output scanners. So you can chain them as much as you need. And same idea with Model Armor. So this is on Google Cloud. It's a service that kind of sits on the side. And every time a user passes something, you pass it through the Model Armor. And then it blocks it or it doesn't block it. And then you pass it to the LLM, and so on and so forth. So it's the same kind of idea here as well. All right. I think that's all I had. So this is a very quick summary of all the things I tried with evaluations and testing and securing LLMs. As I mentioned, if you want the slides, it's here. If you want the code, and I have much more code than I just showed you, so feel free to check out this link. And I think I have like 2 minutes, so if you have any questions, feel free to ask me. Thanks very much.